Okay, so now let's look at the cases in the method of undetermined coefficient. Okay, so we know that we have ay double prime plus by prime plus cy equal to fx, where fx is not equal to 0. Okay, so the for the fx is where case 1 is a polynomial. Okay, so what is the yp? We know that the solution for this method of undetermined coefficient is y equal to y h, which is homogeneous solution, plus the yp, which is particular solution. So we want to know what is yp. Okay, so for case 1, if we have the fx is a polynomial, therefore our yp is given by x power of r cn x power of n cn1 n minus 1 up to c0. Okay, so it depends on the polynomial. Okay, it depends on the fx. Let's say our example here, let's say we have ay double prime plus by prime plus cy equal to, let's say the polynomial is x squared plus 2x minus 1, for example. Okay, therefore we can determine our yp. So yp is equal to this one. Yp is equal to, okay, so we look at our polynomial here, x squared plus 2x minus 1, isn't it? So it will be yp, so x power of r, okay, so cn, so let's say here x squared, so we just make it x2 x squared plus, so 2x meaning that c1 lah, so c1x, so our constant here is c0, so plus c0. Okay, so it will be like this. Okay, so we already can determine the type of our yp depends on the fx. Okay, so note here that we need to choose the value of r. Okay, so r can be 0, it start from 0, yeah. It can be 0, it can be 1, it can be 2. Okay, it depends on the yh. Okay, so we will look at in the example later on, but it depends on the yh. If we can see, is there any similarity between yh and the yp, then we need to make sure that it is the number of r need to be added. So first, of course, we need to choose the smallest one, which is r equal to 0, and then we need to check for the similarity. If there any similarity, then we need to add the value of r, which is r equal to 1, and then we need to check again the yh and the yp. Is there any similarity? So if there are no similarity, then we accept the value of r. If not, we need to increase the value of r, okay, until we cannot find any similarity. Okay, I will discuss in the example later. Now we want to move to the case 2, where fx is in the form of exponent. Okay, so for yp is going to be xr dmx. So example, let's say we have ay double prime plus by prime plus cy. Let's say the exponent is in the form of like 4 exponent minus 5x, for example. Okay, so from here we know that m here need to be in here. Therefore, our yp could be x power of r. Okay, d remain. So whatever number here is doesn't related to the yp. So we just put d. Even though the value here is 5 or negative 4 or half, the yp still d. Okay, so it doesn't affect, but it's effect for this value of m. So here e negative 5x. Okay. Or let's say we have another example. Let's say y double prime plus by prime plus cy equal to, let's say negative half e to x. Okay, so the value of yp basically is x power of r d e to x. Okay, so we have m here. so it's related to here. Okay, so the value of m here will be here. So it doesn't matter whether the constant doesn't affect, it's still d. Okay, alright. Okay, so next one, case 3, where the case 3 is either sine or cos. Okay, so is the yp will be xr c sine beta x plus d cos beta x. It doesn't matter either it's sine or cos, it's still sine plus cos. Okay, so example, let's say we have ay double prime plus by prime plus cy equal to like 5 cos 6x, for example. Therefore our yp going to be x power of r c sine. Okay, so beta need to be the same as the yp. Okay, so the beta here is, in this case, is 6, right? So the value of sine here also, 6 x the beta plus d cos 6x. Okay, so the value of 6 here need to be same thing. Okay, alright, let's say another example. Let's say we have ay double prime plus by prime plus cy equal to, let's say half cos 6, again not cos, I mean sine. Let's say sine 6x. Okay, the same thing, right? Just now 5 cos 6x, now is half sine 6x. Therefore our yp still the same thing, c sine 6x plus d cos 6x. Okay, so either cos or sine. Okay, our yp still sine plus the cos. Okay, alright, got it? Okay, so it depends on the value of beta here. Okay, now let's look at the case 4. Okay, case 4 here is the sum of product of the case 1, case 2 and case 3. Okay, let's look at the case 4 here. If we have sum of case 1, case 2, case 3, let's say f1 is case 1 and f2 is case 2, for example, and f3 is case 3. Okay, therefore of course we need to add up the yp for case 1, the yp for case 2, the yp for case 3. Okay, therefore the solution become yh plus the yp plus the yp plus the yp. So we have 3 different yp's. Okay, so it depends on this case lah. Okay, if let's say case 1 plus case 2, therefore our solution will be this yp plus this yp. Okay, alright, it will be like that. Okay, so it's easy for the summation. Okay, how about product? Okay, product is a little bit different. Okay, so let's say we have a polynomial multiply with the exponent. Okay, so we have the whole thing here, polynomial multiply with the exponent. So the constant over here, suppose we have d, right? So we don't have the d here. Okay, so it will be the constant only at the polynomial. So cn x power of n and so on. Okay, right, multiply with ex. How about the second one? Polynomial multiply with the cos or sine. So it will be polynomial multiply with the cos plus polynomial multiply with the sine. Okay, so the SR here is remain. Okay, how about the exponent multiply with cos or sine? Okay, so we'll have exponent multiply with the cos plus sine here. Okay, if we have both all polynomial multiply with, so exponent multiply with the cos or sine, so it can be polynomial multiply with the exponent multiply with the cos plus polynomial multiply with the exponent multiply with the sine. Okay, so this is how we determine the yp, which is the particular solution for the non-homogeneous equation.